representation. I will highlight it to bodily illusion, probably you know it, the enfacement illusion and rubber hand illusion. The last one is very popular in cognitive science and in cognitive psychology. I can estimate there are more than 1,000 experiments with this design, but absolutely in adults. So that is very popular and investigated different population in adulthood with rubber hand illusion. However, in childhood, this field is absolutely understudied. So that's why we studied it, and I will show you some of it. And I will try to give you some context of these experiments because for the first sight, maybe it seems like a very weird experiment, especially with children. But okay, you will see that. The body and the body representation, and to understand the body representation, how it will develop, is very interesting because it has a very important consequences for different field of the development. First of all, of course, the perception, how we can perceive the information, because the very first experience of the world we collect through our body, even in a womb, prenatal life, that we can collect this information around from the 15 weeks of gestation. When the children begin to move their limbs, arms and legs, and accidentally the baby could touch their face, or that it could generate proprioceptive and tactile feedback. At the same time, of course, the fetus also could touch the uterine wall, for example. So we got many different information, and that is the first information. So as I told you, the body is important because we collect the first experience, and after the birth as well, we collect this information because shortly after the birth, we have a very limited capacity to contact with the bird, of course, limited capacity for perception, visual perception, and then the things and then interaction. So I'd like to say, so that's important to know more about how this different sensory information will integrate during the development and establish the body representation as well as the core of the selfhood, because that will be an important point. Our self, the core self, the body itself. On the other hand, of course, also important to study the body representation from the early childhood, because the body and bodily information is very important for the social cognition and the interaction with partners. Because the children quite often learn from others, and their own experiences often understand from the information for others, so they can understand. This is a bidirectional process I will show you later. Let's see what they know, the children, shortly after the birth. And what would be the key process for developing body representation? The key process would be the ability that the children are able to detect the contingencies between the multisensory information. I mean, they got so that means that baby receive many sensory information from the modalities. Regarding their own movement, and they are able to match this information. If you can see this experiment of Philip Rorschach experiment, he had set of experiment with babies. The babies is in a crib or set on a chair, and this baby can freely move their arms, for example, or move their legs in this picture. At the same time, the experimental setting, here you can see recorded online recording them moving, and immediately presenting on a screen that can the baby see. And the baby from 5 months of old are able to detect the contingency between their own movement and then the scene on the screen of their movement. In a control condition, they can use, for example, a temporary or spatially mismatched videos. So that means the video delay, they use a video delay, for example, 2 or 3 second delay, or they rotated the picture 180 degree. So, and they could make a difference between them. So they'll prefer absolutely when the information is contingent, their own movement and the cited information. So that would be the first important or the key ability that they are sensitive and they can detect this. Another experiment, as the Shomagi experiment, is a recent experiment, is about that also around the 5 month old babies are able to localize vibrotactile stimulation on their limbs. They used a little buzzer like in your mobile phone, and it's a ball, and that was attached to the different place of the limbs, and the babies were able to accurately touch where was the vibrotactile stimulation was used. So it's also about that they are able to localize this information and successfully combine tactile and proprioceptive information. So we can conclude here that they are able to detect the contingency between different sensory information from different sensory channels, and that is important because it has effect and contribution to the ability that the children are able to identify that their body, they have a body, and the different part of the body belonging to it. So that means, and this is the core body representation, and also it has another consequences that they can separate themselves from the environment. So they become an independent entity, for example. So that's the basic mechanism. Despite they are able to detect this contingency regarding their movement, the visual representation about the normal or typical human visual appearance developed much later. I mean, a human appearance and the human body, visual body, has a very typical arrangement, proportion, and and of course a configuration. But it develops around 1 year old, and it's very interesting. I don't know, you know, I hope you know this experiment with the face. When we compare the early face perception studies, the infants are able, shortly after the birth, are able to make a difference between real face and the face when the different part of the face, like here, scrambled, you know. But it's not true for the body because it's developed much later after the 1 year. So, and this information was also supported by neuroimaging studies using EEG. 14-month-old infants start to show a differential neural signals or signature body processing when compared the upright body to inverted body inverse effect. We call it as, of course, that is also known in a face face inverse effect, and it's important because it's important evidence for the unique facial processing configuration and holistic processing. Okay, that was my introduction about this topic. And of course, there are two theoretical consequences, but now I would skip because I'm afraid I won't have enough time. And let's see the rubber hand illusion. Probably, do you know it? You know the rubber hand? Yes, okay.
Yeah, but you explain because
not just an explaining because I have a demonstration. It's an Netflix demonstration, so please handle it that way. So it's more than show than it's a show more than the scientific, but probably it would be interesting and maybe you cannot hear, right?
That's it. Yeah.
Okay, you can see. Okay, there is a rubber hand and the real hand is covered. They can see only the rubber hand and the cotton bud, brush or something stimulated synchronously the rubber hand as well as the real hand.
And you feel the rubber hand as yours.
Yes, the rubber hand is belonging to theirs. So begin to feel body ownership over the rubber hand.
Rubber hand.
Yes. And that is the illusion, that the eyes on the rubber hand seems that you feel the real eyes on your real hand. However, not, of course. That is the trick, of course. That's why it's so important, but it's also exciting experiment using the heat. So,
this is rubber hand.
Rubber hand, absolutely. Yeah, it's a funny.
It's very real.
But the real hand, they cannot feel the same way. So, and then there is more paint test. Pins, using the pins, for example. And a real hand.
That's right, fuck you.
Said nothing.
What? No, it's a torture.
Yeah, it's a torture. I don't know about the ethical issues here.
Summer.
rubber hand. Okay, that was a demonstration of the rubber hand, but of course you should know in the lab we don't use that kind of test of the rubber hand. We usually use more explicit and more exact measurement using the so-called proprioceptive drift. That means before the induction, before the rubber hand stimulation, we ask the participants to close their eyes and on a ruler above the apparatus point to where is the stimulated hand index finger. Okay, and that we measure before the stimulation and after the stimulation. And drift test means if the illusion works, the feeling of the hand position drifted toward the rubber hand. So, and then the difference between the before-after measurement would be the proprioceptive drift. This is an exact measurement of the rubber hand illusion, and of course there is a subjective feeling when there is a question about the body ownership when we stimulated whether they felt the touch and etc. Whether they felt body ownership toward the rubber hand. So this experiment important because it shows that it or gave us information about how our body representation could be very flexible, very malleable, how we can extend depending on the environmental challenges our body. So that is important. But it's also I also have to note here that body illusion is only significant when the information from the proprioceptive, visual, and tactile information is coherent, spatially and temporally. So that means we use a synchronous stimulation on the rubber hand and the real hand, or spatially they are in the same alignment. So when your hand in a horizontal way and the rubber hand in a vertical way, for example, that is the arrangement is different. And in that case, the illusion is disrupted, so doesn't work. And as I told you, this illusion and this illusion is underrepresented in the studies in childhood. There are only, I think, less than 10 studies, including the unpublished studies that investigated the rubber hand illusion in childhood. Dorothy Covey and Andrew Bjornberg had previously some studies. They studied this or replicated the studies among children from 4 years old to 12 years old. And the results show that the rubber hand illusion works in children. Even they showed a larger proprioceptive drift than adults. And it's very important because we know that the children rely more on the visual information than the proprioceptive information. That's why we can see larger effect of the illusion. And but we also know that this illusion not always work. Many adult studies showed that there are huge individual differences whether you are susceptible for the illusion or not. And this is another children's study, but children who were diagnosed with autism spectrum disorder, they were high functioning autistics, but in their case, they don't find the rubber hand illusion. They were very accurate when they have to show where is the real hand after the induction. Probably it's not a surprising thing because the autistic person has a lot of problem with the sensory information, especially when they have to integrate the information from different modalities and different sensory processes, and they quite often tend to show sensory processing disorder as well. So that is a comorbidity of their problem. Okay, and one more interesting thing, whether we can extend this illusion to a different appearance of the hand. Some experiments used dark skin color, so whether we can feel a rubber hand, a completely different hand over the different hand. And these dark studies found yes. It's true. It's true. And so they found that the rubber hand over dark skin hand exists, and they also found, because they also measured before and after the induction, the race bias or a kind of prejudice toward the other races, and they found, of course, it has some effect, but the rubber hand induction was able to change their biases. So the other race biases, that was reduced. So I think it's also interesting. And now I have.
But that was adults, not
it was just an adult. It was just an adult, and so here. I would also noted this experiment because maybe you should know nowadays there are other manipulation of the bodily illusion, relatively new bodily illusion when the researcher use VR, virtual reality, and extend the illusion the whole body. So we can shrink your body, or we can make your bigger the body, the feeling, of course, the subjective feelings, using the virtual reality techniques. Okay, and that was a study when they used dark body avatar, and also they found the same result. But yeah, you asked that is an adult, but replicated the study with children from 5 years to 12 years old in three different age groups. We also used two different skin rubber hand, black and white. And yes, let's see what we found. However, all the experiment was the same that I have already introduced you. Yes, this is just a demonstration. This demonstration would show the proprioceptive drift that we measured. Okay, and here you can see the design. We can also before and after measurement, we measured the explicit ratio bias. It is a very simple measurement, and it's a very, very common. We ask the children to choose 3 friends out of 6, and from photos of the children's. There was 3 white and 3 black children. All was randomized. And we repeated this friends preference after the induction as well. Otherwise, we use the simulation again, black and white, and synchronous and asynchronous, and we measured the proprioceptive drift, and body ownership question was also used. And here you can see the result. With the mixed ANOVA, repeated measure mixed ANOVA, we found only main effect for the stimulation. So stimulation, that means we compare the synchronous and an asynchronous. Only the synchronous we expect the illusion, and we found that, and we find in both situations. So that means that children also could feel the body ownership over the black hand as well as in white hand. There was no age effect at all, and there was no skin effect. And we found almost the same for the body ownership question. We used two questions, and the first regarded for the feeling touch on the fake hand. So that means we asked the children, when I was stroking with the paintbrush, you could feel the touch on the fake hand. And now we can find also only the difference between the stimulation, synchronous and asynchronous. And in the second question, that is with regard for the body ownership, we also found the same. Let's see what we found for the racial bias. Racial bias, we didn't find no significant main effect for stimulation, but we found an interaction between the stimulation and skin color, and it was a quite weak effect. Okay, it's a weak effect. Probably the measurement was not the best, but because for the white hand, we couldn't see any difference before and after the measure for both the synchronous and asynchronous stimulation. There was no effect. However, when we used black hand, wet skin, dark skin hand, we found a very big change between before and after, but only following the synchronous stimulation. So that means the feeling that the body ownership over the dark skin color hand could change a bit of the racial bias. However, of course, it was also, so they have an own race effect, not surprisingly, okay, but that's it. And that we found regardless of age again, right? Okay, and what we know about the infant studies. Best of our knowledge, this is our studies. The first we have already submitted for publication. We hope so. That will be accepted. So we tried to figure out how to test the rubber hand illusion in infancy. We also used, as is very common, looking time paradigm. So the baby sit on the mother lap and watch the computer screen. A computer screen appeared a rubber hand. It was a display. That was a video display, and they watched as the rubber hand was stroking by the brush. At the same time, his hand was covered, so they were not able to see the real hand, but synchronously, we brushed her real hand. So they have a feeling of, so they have an experience, someone is touching their hand. At the same time, they can see the rubber hand that was also stroking. It was they also used synchronously and an asynchronous stimulation as is usual. But we have two conditions. As epicentric view condition, that was the condition which we expected the rubber hand effect, because in this case, if you know, the hand, it looks like that could be belong or that could be continuity of the real hand. But in the control condition, we use a rotated picture, so that is absolutely disconnected to their body. We found again differences between the synchronous and asynchronous stimulation, but only in the egocentric condition, so when we expected it. But we didn't found allocentric view, but okay, they cannot feel the connection with their bodies. Um, yes, yes, that was so. That is the main results that probably show us that the children are able to make a difference between what would be the what what kind of body part would be or belong to her body, and also they can detect the contingency with the stimulation when it was synchronous stimulation. We believe that is the first possible demonstration that in infancy we can show that they can also able to show some body ownership towards the rubber and not a real hand. I hope you can follow it. I'm getting tired, I guess. I hope you can understand this explanation. And one more, another kind of experiment I'd like to show you. It's another bodily illusion, also popular in the last 10 years. This is an enfacement illusion. Here, the researcher focuses on the face instead of the hand or the whole body, but the stimulation logic is the same. So, someone who is a participant watching a video about an unfamiliar same-sex person. Usually, most of the experiments use a women model. At the same time, her face was also touched with a brush or cotton bud, synchronously or asynchronously. When they use this stimulation, synchronous multisensory experience experimentally changes the perceived distance between self and others. Other words, I could say when they feel you are effaced with another person, it seems the self and the other boundaries blur. Okay, so it's not like extend yourself to the other. She is more similar to you. There was an experiment when they morphed the participant's face to unfamiliar, the model face, with a different percentage. You know, we can morph the face with 10 percentage, etc. After the investment illusion, the participants was difficult to distinguish the other person from their real face. So, for example, and of course, it has another kind of effect because after the effacement, we could be more empathetic with the other person, and also we are able to recognize the other person's expression, facial expression, emotional facial expression. We became more conform with the other person and the other thing. Here you can understand, so this bodily illusion has a very important social function. That is, I think, important. Okay, what about children? We replicated this study with emotion recognition with children from age of 4 to 6 years old. Yes, okay. That, that was the design. So we have again a pre-test and a post-test, and between them we have the enfacement stimulation, again with the synchronous and the asynchronous stimulation. There was a display, recorded display, video display that they see. And before and after, the children, that was a forced choice task, have to recognize happiness, fear, and disgust feeling. It was just a labeling process, labeled a particular emotion. And our experiment has another aim. I think it's a quite unique aim because, as I mentioned you, most of the enfacement illusion use only female model. But in our experiment, we wondered whether the children at the age of around the preschool years are able to interface with the opposite sex model, with the opposite sex model. But in our study, we didn't use a male model. Instead of, we involve male children. Okay, so I don't know the opposite way that they would use a male model with a female participants, but that was easier to conduct the experiment. Okay, let's see the results. I will show you the results separately for the emotions. For the happiness, unfortunately, the happiness task was not difficult. Wasn't enough difficult because among the children who were above 5 years, they can quite easily recognize and identify the happiness. So that's we received a simple selling effect. So we cannot use here there, but under the age of 8, we found some improvement, some enhancement of the emotion recognition, both sex. When the model was opposite sex, that means for male children as well as female children. So, and we found again only when the stimulation was synchronous. However, in the control conditions, the asynchronous condition, we didn't find the effect. If you can see here, we collapsed the age, and here we can compare the disgust and fear emotion recognition. We didn't find effect for fear, so there was any enhancement following the stimulation, the induction. There was any, so there was no difference, but as we expected, we found it for disgust, and we found for both sex. So when the model was an opposite sex, also found this illusion. Okay. Okay, conclusion. Of course, this I could say that this experiment and these results just a puzzle. I think to understand the social cognition and body representation, or how the body representation contribute to the social cognition and the everyday interaction. When we compare the classical studies and the classical theories, we could say the classical Piaget study can struggle with that kind of results. And he really believed that infants are egocentric and unable to discern equivalence between self and others. On the other hand, he also believed that in the early years, the sensory information are not integrated in the early years. But nowadays we support more the theories of Andrew Matzoff, the Like Me social developmental framework. He believed that infants can represent the bodily acts of others and their own body acts in commensurate terms. So that means that it's a bidirectional interaction. The baby, his own feelings are able to understand watching the other people's. At the same time, watching the other people's and imitate their action could understand the other people's feeling, intention, mental state, anything at all. So it's a very important. So that's why important that the sensory information in everyday, in early infancy, very, very important. So I would say, especially those people, those children who has some kind of sensory deprivation in the early years. Think about the preterm children who spend even 3 months in the incubator, and they got only some very few information, very few sensory information. But because I said previously that associative learning is very important to develop the body representation and the everyday routine, interacting the baby and the mother together, that is a huge impact. So think about then they touching, then they talking, then interacting, and you should also know, in the last 3 years, there is a new trend in the research that is the affective touching. Affective touching, it's a new renaissance, and they investigated how this affective touching. Now it seems now it's a kind of link between how can integrate. That would be the nice word, I guess. We can say an integration in the science from the sensory studies to attachment studies. So how the baby attach to, and this attachment study, the emotional connection and everything. So I did want to say you, and let's introduce my team. It's a Beatrix group, brain imaging and cognitive experimental psychology at girl power, absolute. We have many different studies from early childhood to adulthood. Mostly we concentrate on the social, cognitive aspects, different aspects, and we quite often involve specific population in our study, preterm, extremely preterm children, autistic children, children with sensory processing disorder, and congenitally deaf children as well. So that is, and that was our university. Yeah, everybody is welcome.
The nature around here.
Yeah, our campus is in a botanical garden. A small one, but we have a nice, I don't know how we can call it in English, this house, that...
greenhouse.
Greenhouse. We have a large greenhouse, and yeah.
And greenhouse.
Greenhouse, yes. Yes. Thank you so much.